morning, everyone. We are Group 1, and today we are presenting our project on the Automated Material Sorting System. Our team members consist of Zhangxi Cheng, Xiao Rui, He Jiakong, and Hu Jiwan. We are excited to share how this system optimizes industrial sorting processes. First, let's look at why this project is necessary. The current process faces high labor dependency, requiring 3 operators to manually handle receiving, measuring, and distribution. This results in high monthly operational costs estimated at 4,500 ringgit. Furthermore, manual sorting leads to process inefficiencies due to human error and fatigue, which creates bottlenecks during peak production times. Our goal is to solve these issues through automation. We aim to reduce manpower requirements from 3 operators down to just 1, allowing us to reallocate human resources to higher value tasks. Technically, we want to achieve intelligent sorting by implementing automatic detection to classify materials as metal or non-metal using sensor logic. Finally, we aim to enhance safety by implementing fail-safe mechanisms and automated clamping. For our methodology, we propose an electro-pneumatic system controlled by a PLC sequence. The hardware includes 2 double-acting cylinders for feeding and sorting, controlled by 5-half solenoid valves with spring return. We utilize proximity switches for material detection and cylinder positioning, and we have integrated start and reset logic with an emergency stop for safety. The system's intelligence relies on advanced relay logic. We use latching memory, or K_auto, to ensure the system completes a full cycle once triggered. A timer, T1, manages a 3-second clamping duration. Crucially, we use a sequential interlock, meaning the sorting cylinder, cylinder B, only activates if cylinder A is extended and metal is detected. Here is the step-by-step sequence flow. Step 1. Detect and clamp. A sensor triggers the system, and cylinder A extends to clamp the material. Step 2. Process timer. Timer T1 begins a 3-second countdown for inspection. Step 3. Decision. If the material meets the requirements, cylinder B activates to sort it. Step 4. Auto reset. Once the timer expires, the logic resets and all cylinders retract, moving on to our simulation. Before physical implementation, we used FluidSim software to design and validate the electropneumatic circuit. As you can see in the diagram, we simulated the interactions between the relays, timers, and solenoid valves. This step was crucial to ensure our logic was correct and safe before we started wiring the actual hardware. Financially, this project is highly viable. By switching to the automated system, we reduced monthly costs from 4,500 ringgit down to 1,700 ringgit. This represents a 62% reduction in monthly costs. The estimated return on investment period is less than 2 months. Here is a brief overview of our bill of materials. Key components include the PLC unit for core logic processing, 2 double-acting cylinders for physical movement, 2 5/2-way solenoid valves for airflow control, and proximity switches for detection. We also use a 24-volt DC power supply and an air service unit to condition the system. Finally, you can see our ladder diagram and our team working on the physical training system here. We have successfully validated the logic and hardware. Thank you for your time and attention. We are now happy to answer any questions. Next, I will present our simulation and ladder diagram.
So this is our group FluidSim simulation. Okay, first we start the simulation. In this simulation, we use 2 push buttons to replace the sensor. So first, we start the system. If the material is heavy enough, we can turn on this push button, and when the material has been detected, we can see that both cylinder A and the cylinder B has worked. If the material is not heavy enough, we can turn off this push button. Okay, push start. When the material has been detected, we can see that only cylinder A has worked.
This is the PLC program experiment of Group 1. Let's begin.
Yeah, that's all. Thank you.